हरिः कर्ता।
So now let's look into the logarithmic and other nonlinear axes. Matplotlib.pyplot supports not only linear axis scales but also logarithmic and logit scales. This is commonly used if data spans many orders of magnitude. So changing the scale of an axis is easy. So let me show you. Logarithmic and other nonlinear axis. So let's take plt dot x scale of log. Of course, this is what it's a logarithmic. On x-axis you got the logarithmic scale. Y is normal, but on x-axis 10 power 0 and 10 power 1 you can attach more. So this is how we can use x scale or logarithmic scale, or we can call it as a logit scales. So we'll take an example. We'll take 4 plots with the same data and different scales for the y-axis. So we'll begin with, so let's fix the random state for the reproducibility. So fixing random state for reproducibility. So np dot random dot seed and 19680001. Okay, next let's make up some data in the open interval of 0 to 1. Let's make up some data in the open interval of 0 comma 1. So y is equals to np, that's why we are taking np dot random dot normal, and loc is equals to 0.5 and scale is equals to 0.4 and size is equals to 1000. Okay, that's our y data. If you just want to see, let me print y, and this is what is our y. Now let's continue. So let me take y is equals to y of, so I'm just want to print it, filter it, y which is greater than 0 and y which is less than 1. Now let me filter y, and this is what is left after filtering. Okay, so now y dot, let's sort. Okay, and after sorting out, so let's make up the x data, x array, the data for the x-axis, arrange and length of y, and let me print x also. I have to scroll down completely, and here is that x. Okay, from 0 till 798. Okay, that's fine. Okay, so now let's plot with various axis scales. Let's plot with the various axis scales. So plt dot figure. Okay, So this is what the size of the figure is 640 times 480. Now let's add the first one is linear one. So plt dot anyway we are taking a subplot of total 4 parts 221, 222, 223, 224. Let's take so 221 and execute. See, this is the first subplot, and inside that I'm gonna plot of x comma y. As usual, I will add labels to that. I'll take y scale. Y scale is linear, and title is also linear, and plt dot grid is true, and execute, and this is your data. Clear? This is a linear. Similarly, we'll create few more plots by changing the scale, how things change. That's what I want to show. And second one is log, a logarithmic. Log, I'll go with the 2 2 2. So right side will get one more. Plot x comma y remains same, and then here it will change to log, and this one the title will change to log, and rest remains same. And here is how things change. So here the values were on, this is the y scale. The y scale has been changing continuously. This is here the y scale has become 10 power minus 2, 10 power minus 1, 10 power 0, because now we have changed to log. So here it is linear, the y scale is linear, so that's why we got 0 to 1.0. But here in this case the the y scale is a log. Let's do more. So this time I'm gonna go for symmetric log. Symmetric log. So let me copy the same everything from here and do the minor modification. So let me change it to 223, and this one I'll change it to let me, so first thing I have to do minor modification in plot itself, because we are going for the symmetric plot. So I'll go for the x and then y minus of y dot mean. That's it. Then here I'm gonna attach a sim log, and then lin thresh, that's a line threshold, is equals to 0.01. Then we have title. I'll change it to simlog, symmetric log, simlog, symmetric log. Then true is a grid, and execute. And here is that. It looks nice. Okay, here there is stacking over each other of this. Okay, there is no enough space. Next, the final one, we'll go for, so length threshold, then we'll go for the log it. Okay, log it. Let me copy everything from here and paste it here. PLT subplot, let me make it 4, and plot simple x comma y, remove other things. Then scale, we'll go for the log it scale, directly log it, and title is also log it, then rest remains. And here is that. So linear log, sim log, symmetric log, and then log it. And this is how, by changing the, and this is first one linear is 0 to 1, whereas for the same thing for logarithmic it's 10 power minus 2, 10 power minus 1, and 10 power 0. Whereas symmetric log, obviously it looks like this, because the 0 starts in between at the center, and then below 10 power minus 1, 10 power minus 2, and then above 10 power, okay, this is minus of, and above is minus This is minus 10 power minus 2 minus 10 power minus 1, on top 10 power minus 2 to 10 power minus 1. Whereas log it, you will have a off at the center, and below 10 power minus 1, 10 power minus 2, above 10 power minus 1, 10 power minus 2, 10 power minus 3. So this is how these things look alike. So now adjust the subplot layout, because the logit one may take more space than usual. So due to y tick labels like 1 to 10 power minus 3. So let's adjust this overall subplot layout. Adjusting the subplot layout. So plt dot subplots. So subplot adjust, and top is equals to 0.92, and bottom is equals to 0.08, and left is equals to 0.10, and then right is equals to 0.95, and head space is equals to 0.25, and W space, that's a wider, is equals to 0.35. We are adjusting all sides. I think all done. So these are, so top, bottom, left, right, horizontal space, and where it's W space. Okay. So let me see, plt dot show and execute, and you got it here. So no more stacking up. So clear cut image, and you got all 4 subplots in a single canvas. Clear? So that's how these things works. It's also possible to add your own scale if you want to add.